these online classes. Hope you will enjoy everything. This time I am with you guys with this new subject, modern methods of structural analysis. It's basically the continuity of structural analysis, but a bit advanced subject than structural analysis. Let's see. Can you see the presentation?
Yes, sir. We can see the
Yeah.
presentation.
Okay. Now, uh, most of teachers our website have guided you about these online lectures and a lot of other do's and do nots and such sort of things. Now, someone trying to mute himself has muted me. The notification is coming who is doing all this, so avoid this sort of thing. At present, you must be knowing all the do's and do nots for these online lectures. Your all lectures will be recorded, so you can refer them at any time later even. The subject, modern methods of structural analysis, as I said, is extension of the structural analysis. In last semester, we have studied structural analysis with a lot of examples. You must be remembering the methods can only be used with simple sort of problems, but the structures themselves, they are collection of lot of members. So if we keep on doing with full scale structure using those methods can take us a lot of time to the point where probably we cannot even complete a job in 2 or 3 days. So some method is always required which can do the job quickly. For that purpose, normally the computers are used because automatic computational power can perform the things very quickly and effectively. To work with computers, all those methods which you have studied in structural analysis are reshaped to use with computers. We will discuss these methods in detail with certain examples and all the formalities and necessities to be done with the subject. Let's see this thing. The subject is 3 plus 0 credit. Simply means we do not have any practical, but only the theoretical classes. Its prerequisite is structural analysis, and you have studied all those things, all the methods, all the required examples in structural analysis. In following 2 or 3 slides, you will see the syllabus of the subject. The separate file for subject syllabus is also uploaded in course material section. You can download uh, syllabus, CLOs, PLOs, and all other related sort of things therefrom. The books are listed over here. 5 books in first section by Saeed Ahmad, R.C. Hibler, Davy Hunton for different topics are listed. Even if you like, it's not mandatory, it's not requirement, but if you like, you can use even the book written by myself on the subject matter or any other book, reference material or anything which you like from the net, from handouts, from other course materials, or from everywhere. You can use as the reference material. Our major concern is to understand the things. Our concern is not to use any specific or particular sort of book, but simply we need some reference material when required to understand the topic. So you are completely free to use any material relevant to the topic. Let's recall, what was the structural analysis? Anybody want to communicate? What was the structural analysis? So it's even written, it's method of checking whether the structure or a structural member sustain the applied loads or not. Load is crucially important. Load has lot of side effects. Load can create lot of problems if the structural member is not appropriate. If it is not designed properly, then probably during the service life, it can cause severe sort of problems. Yes, it's quite okay, 119, that the ability to sustain loads or not. What adverse effects load can create on the structure? Apparently, it's evident we cannot see the loads. We cannot see what's happening inside the structure or structural member. But when load plays its severity, then we can see the cracks in the structural members. The cracks on the surface or cracks may have been propagated inside. A simple example of such sort of thing is during the rainy season. Normally we have observed water gets accumulated on the rooftop. If you do not remove this water, that will remain accumulated, increasing the load on the structure. This load will weaken the concrete in a sense that it penetrates in the concrete pores, then it moves to the steel. When water comes in the vicinity of steel bonded with the concrete, then this water starts corroding the steel. Slowly and gradually, the bond between steel and concrete gets destroyed. The concrete in the vicinity becomes powdered. Steel is rusted. As a result, the volume of steel will reduce. Whatever the diameter of steel was, it will get reduced, resulting in less strength of steel. And the tensile stresses, which are basically supposed to carry by the steel, they will not be carried by the steel, but concrete will be forced to carry those tensile stresses. On the other hand, we all know that the concrete is very weak in tension. It cannot carry the tensile stresses, and as a result, cracks start developing in the zone of steel and concrete. 114 जी बेटा.
Assalamu alaikum.
वालेकुम सलाम बेटा.
How are you, sir?
Okay, I'm putting it on full screen mode. Great. I was because the computer was very near to me, so it was very visible to myself. So I thought probably it's also visible to you guys. Thank you very much. You told me to make it full screen. Now it is full screen. Is it okay?
Yes, sir. Thank you, sir.
Okay,
It is
well,
visible.
particularly when we are
Thank you, sir.
using we are using mobile phone, the screen size is very small, and we need some large sort of the screens to deal with all these things. So let me continue. So this problem of water simply can lead to the cracks. As a result, the strength of the structural member will become very less with time, and ultimately it can collapse. So it is our duty, being the structural engineer, to foresee all the loads which might will act on the structure during the service life and have how much time it will take to solve those 16 equations. Certainly, if I'm not wrong, minimum of 1 hour will be required to solve these 16 equations one by one. So it was not feasible to solve such long sort of equations manually. So simply people's made use of the matrices. We have studied the matrix algebra in ninth class, metric, first year, inter, even in engineering course. In earlier semesters, you must have gone through all the necessary sort of details of matrices. The same matrices are used to solve these equations. You must be remembering a set of equations using matrices can be written as Ax is equal to B. And ultimately, X can be written as A inverse B. So this is a simple sort of explanation that how matrices can be used in our subject. Unluckily, what I believe and observed, this matrix structural analysis, which is an important sort of thing, is not included in our syllabus by HEC, by ourselves, or by PEC. So we are basically missing this thing. If we have learned matrix structural analysis, then modern methods of structural analysis becomes very easy. But so what we have to do, we have even to touch the matrix structure analysis, that how the matrices can be used in our subject. So automatic computational power computers are used to do the length calculations. In first attempt, partial shift from matrix structure analysis was made. As I said, it was the shift by adopting matrix structural analysis. Then, in the second stage, people have shifted whole the methods from normal pen and paper, from matrix structural analysis to modern methods of structural analysis. As is written on the screen, but later, generalized methods for the purpose were developed. These methods are known as modern methods of structural analysis. Basically, at present, three methods are commonly used. First one is the stiffness matrix method. Second one is the flexibility matrix method. And third one is called finite element analysis or finite element method. Okay, let's wait here for a while, buddies. You are now in sixth semester. After 1 year, you will be in the field, serving for one or other organization. Probably Few among you may join those consultancies, consultant sort of firms who they design and build houses, mega projects for others. Can you can you think of how these peoples are designing these structures? Let me take one example. Burj Khalifa, the world's tallest building with 160 stories. People must have analyzed, must have designed the building. How long it would have took them to complete the analysis with 160 stories? Anyone buddies?
So they might have used some software, maybe.
They
There are
might
many
have used
softwares. Some
software.
software. Yeah.
Great. Without software, it's not possible to do the job. No matter it is world tallest building, a bridge, a mega project, or even a simple house, it's not possible these days to complete the job without the use of any software. Can you think of which software might have used for the analysis of Burj Khalifa?
E-step.
It might not be only the one software because it's a mega structure, a lot of challenges, a lot of factors were required to be considered, but primarily you are 100% right e-tapes. This is the name of the software, e-tapes. There are few other softwares also on the list. E-tapes. Can anyone remember the full name of the software? What e-tapes stands for? But is my humble advice. Spare some time to check the details of these technical sort of things. It's not mandatory that you must remember each and everything for these technical sort of things, but at least the points which help you in discussions. Verbal communication always requires simple sort of discussions to deal with the matters. E-tapes basically is the extended three-dimensional nonlinear analysis of building systems. The software is capable of performing three-dimensional nonlinear analysis of building systems. So it is particularly very good for buildings. It's not that good for the bridges or for roads or for other projects. For those projects, there are a lot of other softwares available in the market to deal with the things. The alternative of e-tapes is STAAD, STAAD, ANSYS, and many more. STAAD, sorry, this e-tapes, which have been used for the analysis and design of even Burj Khalifa. This shows that the software is very effective, can even be used to analyze and design the mega structure taller than Burj Khalifa because it was successfully utilized, it was successfully used for Burj Khalifa. So it can be used for a building even taller than this one. Let me share with you guys, buddies, the basis, the background, the solution engine, the algorithms, the methods used in e-tapes is stiffness matrix method. The first one in our list, the stiffness matrix method, is the key component of e-tapes. Same is the case with others. They are also very effective and can be used for analysis of the complete system of structures. And let me mention over here also, these are not the three methods only. Methods are a lot, but the effective, most widely used methods are these three. See the first point, please. These methods are not new. Even then, we call them modern methods of structural analysis, whereas the methods are not new. Some methods are probably 50. Very right. Now, let's take a simple example. Suppose you are analyzing a beam, simple beam of 10 feet length with a central point load in the E-tapes. Okay? E-tape will do the job. Something like a magic job. You will not know what it have done, but it will give you the results. Now, whether the results are correct or not, how you will know the results are correct?
By solving these
That's
methods.
that's the simple reason. You are very right. That's the simple reason. One time at least for one time, we have personally go through all these methods, see how the things are done, how the solution is obtained. Then we do not repeat the things every time manually. But for the learning purpose, we have to do one time all these things. When we are done, when we have the confidence that the method is working fine, then we can shift ourselves from manual calculations to software. Now, with confidence, when we are using the software, the results obtained can be verified one or two times that whether the software has calculated the right thing or not. When this is done, forget about the manual calculation. Do not do it anymore. Just keep on using the software to produce the results for what sort of buildings you are analyzing. But one thing, no matter how good I am at using a software, no matter how good is the software, but every time when software gives results, it's my duty to randomly check one or two members to verify the results are correct. That's
So
the
that
reason.
means,
Jivana?
sorry to interrupt, sir. That means that the softwares are not accurate, or they are not precise. The calculations of the
No,
software.
no. They are 100% accurate. They have well tested. Hundreds of the beta users test the software first, then it goes in the market. But what is point is, do we know each and everything of the software that how it is working? Probably we make a mistake in the input data. Probably we make a mistake in setting up the parameters, which will definitely result in wrong solution. So expertise are always required, but other than that, random check is also required. But you must be, you will agree with one point. No matter how good the software is, no matter how good the method is, no matter how base the solution is, no matter how powerful the calculations are, can they be better than the experience? Never.
Never.
Experience always tells us that whether the things are correct or not. Whenever you have any doubt in any member, in any placement, in any orientation, then we simply use our theoretical knowledge to check that particular member. Let me repeat, not the whole solution, which might take us weeks and months to verify. As I said, Burj Khalifa is the tallest building in the world. Now, if today I decide that I'm going to verify the results produced by e-tapes for Burj Khalifa, probably it will take me more than a year to even count all the beams, columns, slabs, and their loads on them. So we do not perform detailed or complete check, but simply we take one beam or one column and see whether the steel calculated by e-tapes is correct or not. Because software is set of rules, buddies. Uh, I'm sure you have studied in PRC that even if calculations tells us that the steel is not required in the structural member, because we all know buddies, if bending moment is zero, then the steel required must be equal to zero. When bending moment is zero, steel requirement is zero, then being user, I'm free not to use the steel in the structural member, because this is the rule. But on the other hand, every code, no matter it is ASIA, BS, Indian standard, Pakistani standard, Euro standard, or whatever standard it is, all say no matter even if bending moment is zero, the requirement of steel is zero, but you should use minimum steel to deal with the future uncertainties. This is extra steel, is 100% not required, but to deal the future uncertainties, we have to use them. So we have to check such sort of things in e-tape results. Has e-tapes reported zero steel in any member or in any point in the member? If so, we supersede the solution and we should provide minimum steel over here. So basically the bottom line, buddies, is to learn these methods, to understand these methods, to solve some examples by manual method. Using this method is mandatory to develop the confidence, to learn the process. When things are done, you are allowed not to use the methods manually, keep on using the software and just verify the results. Hope it is clear now. If anybody have any question at this point, I'm here to answer, then we will proceed.
No, sir, thank you.
Okay. Few preliminaries, many things we all must be knowing. Here is determinacy and indeterminacy. We all know structural members can be categorized as determinate and indeterminate members. Is it buddies? Determinate members. Which members we call determinate?
When the number of reactions are equal to the number of unknowns.
Sir, equilibrium
Reaction
equations
and
equal
unknowns
to
are same buddies. I'm sorry to say reaction and unknowns are same. Reactions are normally unknown. You are very right, buddies. You are very right, 100%. With one modification only. I'm sure you know this thing, but you are aimed to say that thing, but you have used the unknowns. Is when number of reactions is less than or equal to number of equilibrium equations. Is it, buddies?
Yes, sir.
Number of equilibrium
Sir.
equations. We all know about this. Number of equilibrium equations. By the way, how many equilibrium equations are there?
3.
Sir.
Three.
Three
Are
in
you sure?
two-dimensional system. In
Three in
two-dimensional system.
two-dimensional system. Great. This is the point. 3 in two-dimensional system. Then how about three-dimensional system?
6
Sir, it will
equations.
be I
6.
6
nine,
equations.
nine,
No,
nine.
they are 6.
6
They are
equations,
6
sir.
basically. As we know, it is sum of x, sum of y, and summation of moment equals to 0 in two-dimensional system. In three-dimensional system, it is summation of x, summation of y, summation of z, summation of moment in x plane, summation of moment in y plane, and summation of moment in z plane. Also, moment or rotation, they can be interrelated with each other. There is one more term, buddies. Equilibrium equations and available equilibrium equations. Is there any difference between two terms? Let me repeat. Equilibrium equations and available equilibrium equations. I think available equilibrium equations must be written on this slide somewhere. Yes, it's the second point, third line, available equilibrium equations. Let me see.
Yes, sir, there is a difference.
There is difference. What the difference is? Actually, I was looking for the whiteboard, but all right. As I said, summation of x equal to 0, summation of y equal to 0, and summation of moment equal to 0. These are the three
And we don't
equations.
have,
जी बेटा?
sir, sometimes we don't have y forces acting on the x direction, so we use only two equations. Sum of y is
That,
equal to 0 and sum of moment is equal to 0. These are the
that's great.
available equations.
That's great. That's great. Sometimes we do not have load in any particular direction. The simple example is of the beam. Beam is flexural member. Most of time it is under the action of gravity loads, means loads acting in y direction, perpendicular to the axis of the member. But the loads, 99% times loads are missing in x direction. There is no load in the x direction. So in such case, we cannot use summation of x equal to 0. When we cannot use summation of x equal to 0, then the number of available equilibrium equations becomes 2, not the 3. So if a beam has 3 reactions and equilibrium equations, available equilibrium equations are 2, then the beam will be said indeterminate. We cannot consider over there number of equations equal to 3. If we do so, the beam will be determinate because 3 reactions, 3 equations will define the beam as determinate one. But actually available equilibrium equations are 2, so the beam is indeterminate. So determinacy is the measure of checking whether the member can be analyzed, solved by equilibrium equations alone or not. This we will studied in structural analysis. Determinate members of group.
सर आप म्यूट हो गए हैं।
Sir, you have been muted. Can you unmute mic? Sir, you have been muted.
आवाज नहीं आ रही।
हाँ बेटा, ये फिर कोई म्यूटिंग का प्रॉब्लम आया था। मैं चेक करता हूँ कि किसने किया। कोई ना कोई हमारे ही दोस्तों में से ये कर देता है, उसकी डिटेल आ जाती है, फिर डेफिनेटली कुछ ना कुछ उसके लिए करना ही पड़ेगा। ये डिस्टेंट सेट ऑफ थिंग्स है। अब आवाज आ रही है बेटा?
ये सर आवाज अच्छे भी पर सर हालांकि रिमूव तो करें
जी
सर रिमूव तो करें
Sir, there are some students who are removing us.
स्टूडेंट रिमूविंग यू।
Sir, they are removing us from the.
Again and again. We have to join again.
यो मसलो ॾिसो, असांजो हिक ॿिए सां थो थिए, ठीकु आहे न? जेकॾहिं असीं हिक ॿिए खे रिमूव कंदासीं त पोइ त प्रॉब्लम आहे। इन जो बाबा सॉल्यूशन तमामु सिंपल आहे। इहो तव्हां IT वारनि खे लिखो, गॾिजी करे तव्हां लिखो IT वारनि खे त हीउ मसइलो थो अचे। थी सघे थो हुननि वटि को सॉल्यूशन हुजे जंहिंमें स्टूडेंट खे ब्लॉक करे सघनि।